Hello, my name is Dan Hoy, and I'm a NASA Solar System Ambassador volunteer and a Space Edge Academy contributor. In this three-part series, we're going to learn about three interesting aspects of our solar system: craters, the asteroid belt, and meteorites. So here's part one of our series, craters, craters, craters. Here we go. So as we start our exploration of craters, one of the most obvious questions we ask ourselves is, well, where can we find craters? And for us on Earth, we're quite lucky because our close neighbor, the Moon, has lots of craters on it. And in fact, we can see these craters with our naked eye without the support of binoculars and telescopes. But of course, if you do have binoculars or a small telescope, you can see them even more clearly and you can see more of them. So here we see a picture of some of the craters on the Moon. You'll see that they're round and they have little dips in the center. And in fact, there are so many craters on the Moon that you'll see craters inside of craters inside of craters. Now, there are craters similar to these on all four of the rocky planets that are closest to the Sun, and we'll talk about those. So here, for example, are some craters on Mars that were photographed by a spacecraft passing over the surface. And you'll see that they look very similar to the ones we saw on the Moon. And we'll take a look at some craters on Mars, or Mercury and Venus, and one of Saturn's moons as well. But no matter where we look, we see some tiny craters, some that are medium-sized, and some that are hundreds of miles or kilometers across. In fact, when the Apollo astronauts returned samples of rocks and dust from the Moon, scientists found the tiniest craters you can imagine on grains of sand. But it's the large craters that really capture our imagination. And so here is one of the largest craters on the Moon, and its name is Tycho. It's so large that you can see it with your naked eye, and certainly through binoculars or a small telescope. It's quite large, and you can see that it sprayed out a huge amount of rock and dust in straight lines out from the center of the hole that was made when it was struck by the rock that hit it. There are beautiful craters like these elsewhere as well. So this is a crater called Kuiper, and it's on the planet Mercury. Once again, you can see the large hole or dent in the middle, as well as these long rays that shoot out from the center. In addition, you can see around the hole that was made by the rock, a bunch of material that is called an ejecta blanket, because material was ejected from the crater when it formed. Now we travel to the planet Venus, where we can see the crater Aurelia. So this is Aurelia on the planet Venus. You can see it looks much the same, although the way it threw its material outside does look a little bit different. So we can see craters on all of the four rocky planets closest to the Sun. So that's Mercury, Venus, Earth, and Mars. But we don't see craters on the planets that are further out. So Jupiter, Saturn, Uranus, and Neptune. And why do you think that is? Well, it's because the surface of those planets are gas, and so there's nothing to land on and nothing to disturb. So if a rock hit any of those planets, it would just go through the gas and penetrate to the layers below. However, we do see craters on some of the rocky moons that orbit those four planets. And so this is a crater called Herschel, found on Saturn's strange little rocky moon Mimas. So I mentioned that we can find craters on all the four rocky planets in our solar system, but we really don't see that many on Earth. Why not? Why do you think we don't see many craters on Earth? Well, first, our atmosphere, or the air, causes most meteorites to burn up as they approach from space. They just don't get to the surface because the friction of hitting our atmosphere burns them up. Secondly, over 2/3 of our Earth's surface is covered with water, and therefore we don't see the effects of rocks that land in the water. Third, The surface of our Earth is being constantly made and remade, so craters that formed in our ancient past are all gone, and we could only see the ones that happened in the last several million years. And then fourth, more recent craters on Earth are often worn away by the winds and the rains that we have here. But we do find some. One of the largest and best preserved craters on Earth is Barringer Crater, also sometimes simply called Meteor Crater, and it's in the United States, in Arizona. It's in an area that doesn't get much rainfall, and it's relatively young at 50,000 years old, so it hasn't been wiped away by weather. You'll see that it's quite large. In fact, it's about 3/4 of a mile or over a kilometer wide and about 560 feet or 170 meters deep. To get an idea of how large it is, if you look in the foreground, what you'll see is a parking lot. And the white structures that you'll see are a museum and a visitor center. So it's really, really large. This crater, we think, was formed by an iron meteorite that was about 160 feet or 50 meters across. So you know that it had to be traveling really fast to make such a large crater. Okay, so now we want to learn a little bit more about the different kind of craters you can find around our solar system. And so the one that I want to start with is the large crater. And these are the ones that can be several hundred yards across or even miles across. And they have some features that are kind of special. And so let's talk about those. First of all, one of the things you'll see about the large craters is that they have a very large, high rim around the outside. Because when those big rocks come in and hit, they sploosh up all the rocks that are around the outside and make a ridge that you can see afterward. Another thing about the large craters is that the floor of the crater is usually pretty flat. And the reason why it's flat is that after the big rocks hit, the rock inside there actually melts. And so it melts, stays flat, and then forms that way. Another thing that's really common about these large craters is they have this peak in the center. And if you've ever seen when you drop water into a pond or into something else, sometimes when it splooshes up, you'll get that little peak coming up in the center of a drop. That's kind of what happens here too. The rock splooshes up and then hardens. Something else you'll notice in large craters, and we talked about this before, is that they splash so much rock and dust after they're hit that rock goes out in these long straight lines called rays. And those rays can go from hundreds of feet to hundreds of yards to sometimes miles and miles, like the photos that we saw of Tycho crater on the moon and the Kuiper crater on Mercury. So that's the large craters. They're really beautiful. What's more common though, when we look at craters, is that they're just kind of the common craters that we see here, and they have some differences. The first is that their walls are usually not as tall, and sometimes there's really not much of a wall at all. The other thing that you'll find that's different is for the very small ones, in fact, is that they're not really flat on the bottom. They're kind of hollow and round on the bottom. They also don't have central peaks in the middle, and you also don't see rays. So that's kind of the more common crater that we see more of. And then just a few more. So there are some special or unusual craters that we see sometimes as well. And this first set is what we see a lot on the moon and the other bodies that get hit by lots and lots of rocks. And that's simply that you have craters that are inside craters that are inside craters. And in fact, when they brought the moon rocks back from the moon, they found very, very tiny rocks that they brought back that even had craters in them. A second kind of unusual crater is not round, but it's oval. And the oval craters happen when the rock doesn't come straight in, but it comes from an angle and scoots across the surface, carving out a long hollow crater. And then a third kind of unusual crater is called a chain crater. And this is what you'll see in a chain crater, is a whole series or line of craters in a row. And this is what happens when a meteorite is coming in and breaks apart before it hits the surface. So one part hits here, next one there, next one there, next one there, next one there. So that's a little bit about the different kind of craters that we can find where we find craters. And then the next thing, I'm going to show you a little bit about how you can experiment at home and make your own craters. Okay, now here's the fun part about how you can make craters and study them at home. So most of these things you can find around your house, and it's really a pretty easy thing to make. So let me go through it with you. The first thing that you will need is something to put under all of this, because honestly it can get a little messy. So I usually just unfold a plastic bag and put it on the table and then build everything on top of this. You can use whatever you want, but this I can use, and then I can usually wipe it off and use it again later. Second thing you need is some kind of a pan. It's nice to have a pan that kind of has some high edges because it is going to sploosh out a little bit, and you want to make sure that you can make as little bit of a mess as possible. So this is a 9 by 12 baking pan. Sometimes I use a disposable one like this, but you don't have to. You can use a regular baking pan and clean it up and reuse it without making any waste. So then the first actual ingredient is baking flour. And so this is just ordinary white all-purpose flour. You'll use about 4 cups to fill a pan like this enough. And I don't buy any special kind of flour. In fact, for this kind of thing, I just look for the cheapest flour that I can find. So spread that out as evenly as you can in the pan. Then the next thing, and you don't have to do it, but the next thing I usually add is some colored sprinkles, and I just sprinkle these all over on top of the flour. And they will act as the rocks that are getting blown around by the crater when it's made. You can use any kind of sprinkle you want, any kind of color. I just suggest that you don't use chocolate sprinkles because you really won't be able to see them because we're going to put some cocoa on top. And so that's the next and final ingredient. After putting on maybe a couple of tablespoons of those sprinkles, then somewhere around 3 or 4 tablespoons of cocoa. And once again, I don't use expensive cocoa for this. I usually look for the most inexpensive that I can find. And so if you have one and you can use it, it's usually easier to sprinkle this cocoa on top of the flour using some kind of sifter like this. So I just put the cocoa inside there and then sprinkle it all over the surface. You don't have to get all the way to the edges, but try to get as close as you can. So that's our planet surface that we'll use for our crater studies. And then the next thing you'll need to act as the rocks coming in and hitting are some rocks or some pebbles. And so you'll see here, I have an assortment of rocks, some kind of small, some kind of large, because it is interesting to see the different kinds of craters that are made by small objects and large objects. And that's all you really need. Now, if you're doing a little more scientific study at home, another thing that you can consider adding to this is a ruler. And what do I use a ruler for? Well, I get some note paper, and just so I can study a little bit more about craters, I can measure how high I'm dropping the rock from, because you'll find that that makes a difference. And the other thing is you can measure how large each of the craters are. And that also is kind of interesting to see what size of rock makes the biggest crater and how much difference is the size of the crater if I drop from a low height or if I drop from a really high height. And so that's all you need. So I've made up one of these, a little tiny one, and I'll demonstrate kind of how that works for you in just a second. Okay, demonstration time. So I've made my own small sample of what you can build at home, and I'm going to show you a little bit about what you should expect to see when you have your first asteroid hit, making a crater. So I'm gonna get a stone. You can see, not very large, one of the larger ones that I'll probably use though, and we'll go ahead and we'll drop it from a height of maybe about 1 foot, and hopefully we'll see what happens. So here we go. There's the crater. So if we look down deep inside, what will we see? Well, first of all, we see that it made a hole. So that's number one thing about a crater. The next thing is you'll see that some of the candy sprinkles that I put inside shot out of the crater when my rock hit. And so think about that a little bit. Do you think you'll find more of those sprinkles close to the crater hole or further away? That's something you can look at. The other thing that you'll notice, and it's caused by the flour that was deep underneath, is that we got rays forming. So when the rock hit, it penetrated, went through the cocoa, hit the flour level below, and sprayed it outside the crater hole. So there's a ray, there's one, and there's one. So that's how at home you can learn how to make your own craters and learn a little bit more about what makes a difference. Size of the rock, how high it's dropped from. Hope you have fun with it. Hello, my name is Dan Hoy, and I'm a NASA Solar System Ambassador volunteer and a Space Edge Academy contributor. We're in a three-part series discussing three interesting aspects of our solar system: craters, the asteroid belt, and meteorites. This is part 2 of our series, the asteroid belt, including discussions of asteroids, meteoroids, meteors, and meteorites. Here we go. In part 1 of our discussion, we talked about craters. And in this next section, we're going to talk a little bit about the rocks that are in our solar system that cause these craters. If you remember our photo of the moon, you can see that craters come in various sizes, and that's because the rocks that cause them also come in various sizes. So in this part, we'll talk a little bit about these rocks from space that make these craters, where they come from, how they got here, what happens when they get here, and where we find them on Earth. So most of these rocks that we're talking about come from an area between Mars and Jupiter called the Asteroid Belt. There are large and small rocks here that orbit around the sun. And scientists think that this is an area where there could have or should have been a planet. But for a variety of reasons, they never formed, and there isn't enough material left in the asteroid belt today to make a planet. These large, rocky, or iron objects in this area called the asteroid belt, these are called asteroids. Some are quite large and haven't changed much since they were formed billions of years ago, and others are smaller as the larger ones crashed into each other and broke each other into pieces. The largest body in the asteroid belt is actually large enough that it's called a minor planet or a dwarf planet, and it's called Ceres. It's about 600 miles or about 1,000 kilometers across. It's round, and as you can see, it has its own craters. So how big is Ceres? Well, if you could drag Ceres down to Earth, and you put one edge of it in Des Moines, Iowa, the other edge would be at about Detroit, Michigan. Or, going in the other direction, if that makes more sense to you, one edge would be in Des Moines, Iowa, and the other edge would be in about Denver, Colorado. Now, most asteroids are not nearly as big as Cirrus and go from several miles or kilometers across to maybe the size of a car or smaller yet. Meteoroids are a little different. While scientists don't completely agree on how small is, the smaller rocks in the asteroid belt are not called asteroids, but called meteoroids. So here, think about something like the size of a washing machine or smaller. In this picture, you can clearly see the asteroid that's off on the left-hand side, and if you look very carefully off to the right, you'll see the tiny meteoroid, just to give you an idea of the different sizes that we have. Now, most of the time, asteroids and meteoroids happily orbit around the sun, occasionally bumping into each other, but not moving around a whole lot. But sometimes the gravity of the other planets can push one of these out of their orbit. Now, when this happens, sometimes the asteroids or meteoroids shoot out of our solar system altogether, and we don't really know where they go. But sometimes they get pushed toward the sun. And sometimes, as they're making their trip around the sun, we're in the way. If a small meteoroid hits our atmosphere at the super high speed at which they travel, it'll warm up, eventually getting so hot that it melts and forms a bright streak of light across the sky, like the one you see in this picture. And maybe you've been lucky enough to see a meteor as well. Meteors are sometimes called shooting stars or falling stars, and the ancient people, because they saw these things that looked about the size of a star, thought they were stars. But of course, we now know that they're actually bits of rock and ice and dust, and that they're not stars at all. Now, most of the ones that we see in the sky, most of the meteors, come from rocks that are quite small. Think of the size of a garden pea or even a large grain of sand. So every once in a while, a meteoroid is so large that it doesn't completely burn up in our atmosphere and it lands on Earth. These are called meteorites. So meteorites can probably be found by anyone, anywhere. But many of the meteorites that we find are found in the Sahara Desert in Africa or in the snow and ice fields of Antarctica. Can you think why that might be? Well, the Sahara Desert is mostly sand and Antarctica is mostly snow and ice. So if you find any rocks there, there's a very good chance it's a meteorite. So those are very good places to search for these. So everyone loves meteorites, including regular folks like you and me, but scientists, museums, and universities get very excited about them because they let us learn about the asteroid belt without having to go hundreds of millions of miles to get them. Hello, my name is Dan Hoy, and I'm a NASA Solar System Ambassador Volunteer and a Space Edge Academy contributor. In this three-part series, we've learned about three interesting aspects of our solar system: craters, the asteroid belt, and meteorites. In this third and final part of the series, we'll learn about the three major types of asteroids and meteoroids that we've learned about by studying meteorites that fall to Earth. Let's check it out. I'm lucky enough that I have a small meteorite collection, and so I'm happy to share with you today three of these that represent the three most common types of meteorites that we find. The first is called the stony meteorite, and that's this one right here. So this is an actual meteorite that landed in the Sahara Desert of Africa, and it's the most common type that we find on Earth. As you can see, it looks much like an ordinary stone that we might find on Earth, and in fact, it's quite similar. However, scientists can use sophisticated chemical and other tests to show and prove that this rock did not come from Earth and came from somewhere else, the asteroid belt. There are simpler tests to help people get started to know whether they have a meteorite or not, and one of them is to test whether or not the rock is magnetic. So some Earth rocks are magnetic too, but nearly every stony meteorite has enough iron and nickel in it to be magnetic. So you can see, if I put this small magnet on, it sticks because it is magnetic. The next one we're going to talk about is the iron meteorite, and it's the second most common type of meteorite. And that's this one right here. And you can see that, of course, it looks quite metallic. It's shiny, feels like metal, it's very dense. And you can even see where it kind of melted a little bit, either when it entered the atmosphere or when it exploded upon landing on Earth. And one of the things that's typical of these iron meteorites is that it is super magnetic because it has such a high content of metal. And in fact, it's so magnetic that it's kind of difficult even to get the magnet off. So scientists think that the iron meteorites may have been the cores of early planet-forming bodies in the asteroid belt before they were somehow cracked apart into rocky and iron parts. Then, the third type of meteorite that I'll show you here is the rarest, and maybe the most interesting type of meteorite, and it's called a stony iron meteorite. It's easy to see why it's called this, as this sliced sample shows both the rocky parts and the metal parts that are inside it. And scientists, in fact, think that these are a mashup of the two major types of meteorite, the stony and the iron. So either a stony asteroid and an iron asteroid collided and then melted together, that's one possibility. Or maybe a planet was starting to form with an iron core and a rocky outside, and somewhere along the line it got hit, and some of the pieces that broke off were at this border in between the metal and the rocky part. The final part that I'll share about this is because it's an asteroid and has metal and stony components, it also is very, very magnetic. So those are the three major meteorite types, described by the kinds of materials that they contain. There are other ways to classify meteorites too, and there are even categories within each of these three main types. But now you know more about our neighbors in the asteroid belt, the three main types. And maybe you'll be lucky enough to see a meteorite someday. In the meantime, I've been happy to share with you some of my meteorite collection and show you the three major types.